Okay. Our job today is to be able to multiply fractions and multiply mixed numbers. And a few rules that you need to know. Now, for some of you, if you don't know numerator's the top number, denominator's the bottom number, if you don't have that down, you might need to write it down. I'm going to refer to it as both the numerator as being the top and denominator as being the bottom. So when we look at multiplying fractions, it's always top times top and then bottom times bottom. Okay? Or numerator times numerator, denominator times denominator. And that should be a review from what we did at the end of last chapter. Should be something that you did even last year in math class. Okay? The second piece that we're going to talk about is going to be about mixed numbers. And we'll get to that. And then we're also going to talk about whether you should simplify before you multiply or multiply and then simplify. We're going to talk about why you can do it either way. Does that make sense to everybody? So those are our goals for today. To make sure we understand top times top, bottom times bottom. Okay? We're going to talk about what we need to do with mixed numbers because there's something special that we have to do with mixed numbers. And then we also need to get into either multiply and then simplify, and that means putting it in its simplest form, or you can simplify before you multiply. And we'll get into that as well. All right? So, if we follow these rules, what I want everybody to do right now in their notebook is I want you to do 4/5 times 1/3 and follow the rules. Numerator times numerator, denominator times denominator. Let's go. Okay, what I'd like you to do right now is I'd like you to share with your new table partner. What'd you get? All right, and just from hearing what many kids got, I could hear a lot of you. And I bet you can hear, when you go back and watch this video, I bet you're going to be able to hear it. Because there's a lot of kids that said, what, Emma? 4/15 because ice. Numerator times numerator is equal to 4. 4 times 1 is 4. Denominator times denominator is 15. My answer is 4/15. Now I want you to look at this real carefully, and I want to see if anybody can answer this question. Everybody agree that 4/5 is pretty close to 1? Okay, and 1/3. Now 1/3 is kind of close to 1/2. It's pretty close to 0. It's kind of right in between. In fact, it's a little bit closer to 1/2. But look at our answer here. Is this even close to 1? What I want you to do right now is just discuss with your team. All right, so the question was, why did our answer get smaller? In fact, watch. If I took, what's 1 times any number? That number, right? So 1 times 1/3 is 1/3. And if I wanted to figure out, is 1/3 bigger than 4/15, or is it smaller? It is a little bit smaller, and here's how I know. Find a common denominator. Let's use 15. I just multiplied by 5 on the bottom and 5 at the top, and look at this product right here is even less than this one right here. And so the question I asked you is why? Why do we get smaller? Do you guys want to know? Good. When we multiply any number by 1, we get that number, don't we? What happens when we multiply by 0? You get 0. You get nothing, right? Four groups of 0 is 0. We are taking a number 4/5. It's less than 1, but it's greater than 0. If 0 times 1/3 is 0, 1 times 1/3 is 1/3. Something less than 1 must give us a smaller number than 1/3. Does that make sense to everybody? So when we take two numbers that are less than 1, we have to get a smaller number. Okay? And even look at this. I mean, what happens when we take 4 times 1/4? Is 1/4 less than 1? 1/4 is less than 1. What do we get when we take 4 times 1/4? What? Yeah, but what do we get? We get 1 whole. Did we get smaller? Well, we start at 4. Did we get smaller? Yeah, because we're multiplying by a number that's less than 1. That's why when you multiply by numbers that are less than 1, our product, our answer of multiplication problem has to get smaller. It's an important thing that everyone needs to know. Okay? That way we can estimate answers. Think of just take half of any number. Half of any number, we're going to get smaller. And of means multiply, so that we're multiplying by 1/2. We get smaller. All right. Now, we're going to move into the next part. We understand top times top, bottom times bottom, numerator times numerator, denominator times denominator. Here's our mixed number piece. For mixed numbers, we must convert all mixed numbers to improper fractions. And then multiply top times top and bottom times bottom. Okay? So an example of a mixed number is like 3 1/5. We have to convert this mixed number into an improper fraction. What is 3 1/5 equal to as an improper fraction? Okay. 16/5. Can you explain how we got 16/5? Okay. And why can you do that? All right. She said, and this is what many of you memorize. We do 5 times 3, and then we add 1. The reason why we do 5 times 3, that equals 15, right? 3 is equal to 15/5. Does everybody agree? Right? Because 15 divided by 5 is 3. That's why we do 5 times 3. That gives us 15. That means that we have 15/5. That's what that 3 stands for. And then we have 1/5 more. So we add 1 more fifth and we get to 16/5. Kids, you have to have that part down. In fact, for just about everything we're going to do this chapter with mixed numbers, many of us are going to prefer going to improper fractions. When we divide, we have to do the same thing. We have to convert to improper fractions. When we multiply, same thing. When we get into subtracting, many of you are going to prefer just to convert everything to an improper fraction. Now, I'll show you another way, but that might be the preferred method that we have to use. So all mixed numbers, when we multiply, have to be converted to improper fractions. Okay? So here's what I want us to do. How many kids made cookies over break? Did you help make cookies? Did you make them yourself? All right, good. All right. Now just imagine, sometimes you get these recipes for cookies and you need to make them not only for you, but for, your cousins and maybe your grandma and grandpa or whatever. You're bringing over a big batch of cookies somewhere to some party, right? Well, what happens if Marwan just wants cookies for himself? He doesn't need the full batch, does he? In fact, in this case, he wants 1/4 of the recipe. Okay? 1/4 of the recipe. So if Marwan wants 1/4 of a recipe, and the full recipe calls for 2 2/3 cups of butter. A lot of butter. I bet those cookies are good. How much butter would he actually need to use? Okay? Now I'll give you a hint. This question is 1/4, and I want everybody to see this. Everybody watching? It says 1/4 of. If you need to write this down, write it down, circle it, star it, underline it. You need to know it for the rest of your life. 1/4 of. What's the word of mean? Times. Write that down. Of means times. And you guys should already know that. 2 groups of 3. What does the word of mean?
Multiply.
Times. Okay? So when we see it in these story problems, we need to really look at that and say, oh, I see of. I see of. That's an important word. Guess what it means? Multiply. So that means we need 1/4 of the recipe. Well, what is the recipe? The recipe consists of what? 2 2/3 cups of butter. So here's 2 2/3. We want to find 1/4 of 2 2/3. Everybody see how we can break this problem down?
Yep.
All right, now, I just told you what we need to do to multiply mixed numbers. I'll leave it up here, but I want everybody to try. Tell me how much butter we need if we're making 1/4 of that recipe. All right, we're back. Now, step number 1. Did you follow the rules?
Yes.
For mixed numbers, did you convert the mixed number to an improper fraction?
Yes.
Okay? All right, if you did, since you said you did, can you tell me 2 2/3 is equal to how many thirds? 2 2/3 is equal to what improper fraction? 8/3. Is 8/3 correct?
No.
Shh. So our problem should be 1/4 times 8/3. And we got that because 3 times 2 is 6. That means that 2 is equal to 6/3. Everybody agree? 6 divided by 3 is 2. Okay? Then we need to add this additional 2/3 to 6/3, and that's how we get 8/3. All right? We're good to go. Now, when we get done, we get 8/12. 8/12 what? Cups of butter. Very good. 8/4 cups. Remember those labels. Okay? Now, I got a question here. Dunny.
Mr. Mike, can we use the distributive property?
Did everybody hear that? He said, Mr. Martin, can we use the distributive property? Should we try it?
Yeah.
Okay, so if we're going to use the distributive property, that means that we can take 1/4 of 2 and then add that to 1/4 of 2/3. Does anybody know what 1/4 of 2 is? If we take 2 and make it 1/4, so let's see. I'm going to do, you're right, it is a half. Here's 2 right here, right? If we said half of 2, this is 1/2 of 2. Half of 2 is 1. So then we need to take half of a half, which is 1/4. Half of 1 is 1/2. All right, so 1/4 of 2 is 1/2. We're going to take that 1/2 and add it to 1/4 times 2/3. So let's just do top times top, bottom times bottom, right? 1 times 2 is 2. 4 times 3 is 12. 4/12. Now I'm going to just, I'm sorry, 2/12. Whoop, thank you, 2/12. Let's not confuse anybody. I'm going to simplify 2/12. 2/12 to, you know what, I'm going to keep 2/12. I'm going to keep 2/12. And I'm going to add that to 6/12 is 1/2. And what's 6/12 plus 2/12? Did we get the same thing? And then we need to simplify it, and it actually equals 3/4, right? No, not 3/4. 2/3. Thank you, 2/3. Are we good on that? Okay, so can you use the distributive property? You can. I don't recommend anybody does it. Unless you truly understand it, you can do it. But I would just say Let's stick to this right here. Let's just convert to an improper and go from there. How many kids got it right? How many kids got 8/12? Awesome. 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 If you didn't, did you see where your mistake is? Okay. All right. Next page. Now our next piece. And you guys are doing an awesome job. I'm going to send you loose pretty soon. We got this last page. And this is a method that you can use if you want to. Some of you will want to do this because it makes your multiplying so much easier. Now, I just have a question for you, and I want you to think this in your head. Would you rather multiply big numbers, or would you rather multiply small numbers?
Big and small.
Okay. Shh. All right, so for example, how much would you guys really want to multiply 15 times 8? Shh. Well, it's 80 plus 40. It's 120. I use the distributive to do that. 8 times 10 is 80. That's this 10 right here in the 15 times 8. That's 80. And then 8 times 5 is 40. 40 plus 80 is 120. That's the distributive model. Okay? Shh. Now, some of you are going to say, Mr. Martin, come on. I don't want to do that. So then you might want to choose this method. And it says we can choose to multiply and then simplify. That means you just got to multiply the numbers as is. Or we can simplify before we multiply. Okay? So I want to show you. Do the numbers in the black share a common factor? So does 2 and 8 share a common factor? Okay? Write down what that common factor is. Write it down. And then what we get, class, is the common factor? That would be a 2 is the common factor. 2 goes into both 2, because 1 times 2, and 2 goes into 8, 2 times 4. All right? Do the numbers in red share a common factor? 3 doesn't go into 5. It is 5. Okay? Okay? Now, oh, okay, sorry. Here we go. We're being picky here. That's fine. We can use our little colors here and say 5. Okay? If we multiply, if we just do straight up multiplication, watch what we're going to end up doing. What's 5 times 2? Okay? 10, and we said that 15 times 8 is? Now, to simplify, we just find common factors of both numbers. And guess what the common factor is for both of these? Very good, it's 10. We have to divide by 10 on the top, which gives us 1, and divide by 10 on the bottom, and that gives us 12. Here's the simplifying before you multiply. Okay? Okay, that's fine. There's nothing wrong with doing it this way. But watch how I'm going to simplify and take out 10 right away. 2 and 8 share a common factor of 2. Is that right? That means when we multiply both the top and the bottom, we're going to have a common factor of 2. Does everybody see that we can take 2 out of both 10 and 120? Okay? So if we look at these cross products here, we can simplify and take out the 2's right away. 2 divided by 2 is 1. 8 divided by 2 is 4. Now, we said that they have a common factor of 5 as well, right? Does everybody see a common factor of 5 in both 10 and 120?
Yes.
Yeah. So if we know that they're going to both have that common factor, why don't we take it out ahead of time? What's 5 divided by 5? And 15 divided by 5? Now look what I get. What's 1 times 1? 1. What's 3 times 4? If you simplify before you multiply, and you break it down as low as you can, you will get your answer in simplest form. Okay? Now kids, here's the deal. whether you multiply and then simplify or simplify and then multiply. Do you see how I got the same answer either way? If you don't want to use this method, you don't have to. Will this method save you time? Sure. Maybe what some of you should do, if you're a little unsure about this, just do top times top, bottom times bottom, and then simplify. Okay? And then after a while, you're going to start seeing, oh yeah, you might get it. It's for some of you, if you already have this down, you say, you know what, I get this simplifying beforehand. I know that I can simplify the cross products because I know if I'm multiplying by 15 on the bottom and 5 on the top, that this has to have multiples of 5 in it. It has to, or factors of 5, a common factor of 5. And if I'm multiplying by 8 and 2, guess what? Both the top and bottom have to have a common factor of 2. Okay? So if you want to do that, you certainly can. Here's what we're going to work on today, and I'm going to give you, I hope, you got a big chance to get all this stuff done today. Okay? Our homework, it's on my webpage already. I put it down on there. I think everybody should pull out their planners right now and copy this down. Page 218 and 219. Numbers 31 through 49 odd. And then we're going to do the spiral review, which is 52 through 55. We're going to do, whoop, that's not odd, that's all.